Hi guys, I'm going to explain real quick about this question, this problem from section 3-2. This is actually one of the problems in your turning assignment number 2. I don't usually like to answer question on those because those you'll be graded on. Usually there are a lot of homework, or there's some homework assignment that should be similar to the these types of questions. So I mean, I can answer question on homework for sure, but on the turning assignments, of course, because you have to now after you have the grade, after I grade them for you, then of course after that it doesn't matter. I usually give you the solutions anyway, but before then I usually don't like to answer a question on those. But this actually involves a concept called the closure. So I'm going to go ahead and actually work it out for you, but most of the time you should look into the homework. And I think there's actually problem number 9 in the same section in assessment part A, which is one of your homework. I think that problem number 9 is very similar to part A of problem number 8 from assessment B, which is from your turning assignment, okay, number 2. Anyway, I'm just going to work it, explain to you real quick, and then hopefully you can also look for more homework assignments similar to question you may have later about the turning assignment. So the question part A, there's part A. Let me start with part A. It says set A is closed under the addition and contains the numbers 2, 5, and 8. Okay, but the most important thing here, of course, is the idea of closure. Okay, so let me just explain to you. To say a set is closed under addition means that if you take any two elements of that set, and if you perform the operation of addition, you get this number that also belongs in the same set, okay? And that's what it means to say a set is closed under addition. So, for example, if you look at the set of whole numbers, 0, 1, 2, 3, 4, 5, this is, of course, the one we call set of whole numbers. This set is closed under addition. Why? Because if you take any two whole numbers, if you add them together, you're going to get another whole number, which is back in the set, okay? So that's what closure means. So in this problem, he's giving you basically three numbers, and he said that for you to come up with 6 other elements or members for the same set. So really there's many different correct answers, actually infinitely many correct answers. So all you have to do, because it's closed under addition, you just basically combine the numbers. You can even add the number to itself. So like 2 plus 2, 4 should be there. 5 plus 5, 10 should be there. 8 plus 8, 16 should be there. I mean, this is only one choice. There are many choices. You can also add them together. 2 plus 5, that's 7. 2 plus 8, that's 10. 5 plus 8, 13. So there is just 6 other numbers that must be in the set if it's going to be closed under addition and if it contains these 3 numbers. Okay, because remember, to be closed means if you take any 2 members or even the member itself, add them together, the result must be in the set. Otherwise, it cannot be closed under addition. Okay? Now, part B asks the following question. But again, let me just say, in part A, everybody in the class can come up with 6 different answers because you have many different options. But this is probably some of the more basic ones. Part B says, the set A contains the element 1. What other whole numbers must be in the set A to be closed under addition? So if the set has 1 in it, and remember now, to be closed under addition means if you take any member added to itself or any other member, the result must be back in set. So if you take 1, and if you add 1 to 1, you get 2, which means, of course, 2 must be here. If you add 1 and 2, you get 3, so 3 must be here. If you add 3 and 1, 4. So that tells you that you must have the rest of the whole numbers, the 2, 3, 4, rest of the whole numbers in order for this set to be closed under addition. Okay, I hope that helps. Let me know if you have more questions.